Good morning. I am Cheryl Warner from NASA's Office of Communications. Thank you for joining us today to discuss this incredible booster test that we all just witnessed for the most powerful rocket in the world, NASA's Space Launch System. The test was conducted today, Tuesday, June 28th at 9:05 a.m. Mountain Time at the Orbital ATK Propulsion Systems Test Facility in Promontory, Utah. This was the second and final qualification motor test of the booster before it will be ready in 2018 for SLS's first flight with the Orion spacecraft and represents a major step for NASA's journey to Mars. The next time one of these boosters fires up, it will be on the launch pad at Kennedy Space Center in Florida for Exploration Mission 1. Here to discuss initial data from the test are Bill Gerstenmaier, Associate Administrator for Human Exploration and Operations at NASA headquarters in Washington, Charlie Precourt, Vice President and General Manager of Orbital ATK's Propulsion Systems Division in Promontory, Utah, and Alex Priskos, Manager of the SLS Boosters Office at Marshall Space Flight Center in Huntsville, Alabama. Each speaker will provide brief remarks, and then we will take questions. We will start with a few questions from the room, and then open up the phone lines for questions. Please stick to one question, identify yourself if you are in the room, and to whom your question is directed to. And then, for those listening on the phone line, your phones are on mute right now, but if you want to enter the queue to ask a question, please press *1. The operator will call on you and open your mic when we're ready. First, we will hear from Bill Gerstenmaier. Bill?
Thanks, Cheryl. What an absolutely amazing day today. I mean, just a great chance for all of us to get a chance to be here and actually witness this test firing. And it's not just a test firing, it's really a qualification motor test firing, which fits in a sequence that essentially says this design is ready to go fly and ready to go do the mission to which it's designed to go do. And it's also really exciting for me to get a chance to go walk around and talk to some of the folks that have been working so hard to get this configuration ready and to get this rocket ready to go fire this morning. And just what excitement the team has, how excited they are, and what a tremendous professional job they did to get all this firing to occur. And it's not just the firing that we saw. They're going to get a lot of data. There's over 500 channels of data on this rocket. They'll be pouring over that data to make sure that it performs exactly the way we intended it to perform with these cold conditions. And that data will be really important to go ahead and say things are certified. And it's also exciting because they're also starting to actually cast the new booster segments for the actual EM1 right here at the plant. So it's not just this test firing, but we're actually moving forward. When I look back at the bigger program, I see what's happening down in New Orleans with the external tank. The hydrogen tank is almost through qualification. It's almost welded, ready to go into its qualification testing. The Orion capsule for EM1, it's down in Florida. It's undergoing final outfitting, again, heading towards that EM1 launch in 2018. So to some folks, 2018 seems like a long way away. To me, it's not that far away. We got a lot of work to do. We know what the schedules are. I have 100% confidence in this team. They can deliver under amazing circumstances. They did really good today. We should all enjoy this moment, but then just celebrate for a little while and then get back to work. We got a lot of work to get ready to go for EM1. So thanks again for having us. And Charlie?
Thank you, Bill. Thanks for those words, too. We've got a team here that's been working really, really hard for quite a long time. The last 5 weeks in particular, our test team has been working around the clock, running numerous, countless almost dry runs to make sure this came off very well today. Had to deal with a couple of technical glitches that we handled on the fly. The team did an outstanding job with that, and we got the test off. And as you saw, the immense roar of the booster was just really a delight. I never get to a point where I'm so used to this that I'm calm. I think we had the entire workforce here was on butterflies, and when they asked me what it would be to signal that it was complete and successful, and said, as long as you see flame for 2 minutes and 6 seconds before you see tail down, we've done the vast majority of the work, because that's what we need when we power crew on out beyond low Earth orbit, is for those boosters, 2 of them, to work beautifully in tandem to get crew. For the first time in a long time, we'll be taking crew out beyond low Earth orbit. And as Bill said, we're now working in parallel with the production of the EM1 hardware. 3 of the motors have been, the segments have been through casting. Several others are in processing to be cast with propellant and prepared to be shipped to Florida. So this is a really exciting day. Great milestone for us. We now feel really confident at our ability to perform here, going into the next steps of the program. And we're just really excited to be a part of sending crew onto Mars one day. So thank you for being here. Making the trip all the way out here. A lot of people came from a lot of different places around the country. Really appreciate the effort you made to join us today. Thank you. Turn it over to Alex Priskos, our program manager for the booster.
So I'd just like to thank Charlie and his team. What an outstanding test. This was fabulous. If this isn't fun, I don't know what is. They did a great job. The motor is, as far as it, absolutely no issues thus far. We've had a chance to look at just some very, very preliminary data in terms of ballistics in the TVC, and everything looks great so far. We're going to be digging into data a lot more as we go forward. As these guys mentioned, they've got several other qualifications tests that they've already performed on some of the forward structures. We'll be putting that and this together with a bunch of other data to have our design certification review in the next summer. And believe it or not, we're going to be delivering hardware in the fall of next year to KSC. So it is not that far away. When we talk about 2018, for those of us that are worried about delivery schedules and that, it's just around the corner. So again, congrats to the ATK team, the professionalism this morning and this whole time leading up in the production and conducting of this test was phenomenal. So thank you.
Thank you, gentlemen. We will now move to question and answer. If you're in the room, please raise your hand. Amber will come by with a microphone, and we'll start with Jason.
Hey, Jason Ryan from SpaceflightInsider.com. Charlie, I was hoping you could give us a little more background about the glitch you encountered and just tell us what your team did to work in real time. Thank you.
Yeah, I'd be happy to. That was from Jason asking for those on the phone, the glitch that we had. So we have a number of computer systems in line with the motor. Some of them command the motor, some of them take data. This was called a sequencer, and it's responsible for starting up and the right timing of the startup of a number of pieces of equipment. That had been run perfectly for all of the dry runs, and then when we booted it up this morning for the test, of course, we got a failure to link in its communication. So we had to change out a hard drive with another version of the software in it to make sure that we could proceed with the test. And the team did a really good job of working their way through that. We'll go find out what was going on there. Fortunately, we were able to work offline in parallel. Guys and gals are getting the rest of the systems ready, and 1 hour delay is not really significant in the grand scheme of things here. We got all the data that we wanted. The sequencer worked perfectly during the flow, so we're really, really happy with what we got.
Great. Before we go to our next question, as a reminder, if you're on the phone line, please press *1 to enter the queue to ask a question.
Thank you. Sean Costello, Spaceflight Insider. Question about the timing. Given the heat today and that this was a cool down test, could you tell me what the tolerance was for acceptable window to push?
Sure, you want me to take that? So our acceptable window was between 35 and 45 degrees of mean bulk temperature, okay? It was 41 degrees at the time of the test. So we were right about where we wanted to be. We were shooting for 40, we were just slightly under 40.
Outstanding, thank you.
Hi, I'm Jason Lee with the Deseret News in Salt Lake City. Just for the average person, what does this test mean? Obviously, you feel like it's been successful. What were the objectives, and what does it mean for the future of spaceflight? Charlie?
Okay, the question has to do with, for those of us that are local here, what does this test mean for the future of spaceflight? We are on a journey to take crew to Mars and other destinations outside of our immediate Earth low orbit that we've been working in at missions like the space station now. All of those missions in the past link together to enabling us to go further. And the journey to Mars requires a lot more power, a lot more capability to lift. To give you a reference point, the shuttle, when it lifted off, was about 7 million pounds of thrust total between the 2 boosters and the 3 main engines. The new Space Launch System will be about 9 million pounds of thrust for the 2 boosters and the 4 main engines on the core of that vehicle. And so these 2 boosters had to be stretched from what we had on shuttle. 25% more length and propellant results in a booster that went from 3 million pounds of thrust to 3.3 million to 3.6 million pounds of thrust. And then along the way, in meeting those challenges, we dealt with improvements to design, manufacturability, and so forth, the things that we've learned over the years to make sure that this booster provides the best performance possible. Because when you consider space station is 200 miles, 160 miles to 200 miles up, the moon is 250,000 miles away, and Mars is 35 million miles away. We're talking about being capable of providing tremendous delivery of systems, hardware, for the crew to be able to handle that journey. So we're just really proud here in the Salt Lake Valley to be a big part of that with the boosters and the thrust that we provide to get them off the plane.
Thank you. Any more questions from the room? All right, we'll go to the phone line. Operator, do we have someone on the line?
We have Bill Harwood with CBS News. Your line is open, sir.
Thanks. I'm not sure who it's from. It's really kind of a nuts and bolts basic physics question, but when you go to 5 segments, can someone tell me, does the internal pressure in the rocket, is it roughly the same as 4 segments, or does it go up? And just maybe some of the constraints to go to 5 segments in terms of things you had to beef up, that sort of thing. Sorry for the basic question, but I'm just curious. Thanks.
No, very good. This is Alex Priskos of the NASA Booster Office. The question is the pressure. When we went from 4 to 5 segments, what did we do? Did we adjust the pressure, or did we keep it the same? The pressure is actually governed by the heritage cases, and so we had to keep the internal pressure, operating pressure the same. And as you pointed out, we had more propellant. So in order to do that, we actually open up what we call the nozzle throat. So it keeps the pressure the same. So that resulted in 2 things. Our thrust, our total impulse went up by 25%, but our thrust only went up by 20%. We kept that operating pressure today just like it was on shuttle. It's in the realm of 900 PSI or so. Hope that helped.
Yeah, that's exactly what I wanted. Thank you very much.
And we'll continue to take questions from the phone, please.
Our next question is from Frank Mooring with Aviation Week. Your line is open, sir.
Thank you. This is for Bill Gerstenmaier. Looking forward beyond EM1, how are you doing on EM2? And specifically, does it look like you're going to be able to get that flight off early enough to begin work on the exploration upper stage? Thank you.
Yeah, again, we're not only doing the uncrewed flight of EM1 in 2018, we've got plans in place to do a crewed mission, EM2, in roughly the 2021 timeframe. And again, we're moving forward on all aspects of that just as well. There's an Orion capsule, as I described to you earlier, is in Florida. It's actually going through processing for EM1, but then we have another structural test article actually for Orion capsule in MAF being manufactured, being put together. That welding is coming together. That will certify for the environments to take crews moving forward. We've been working with the Europeans to work on the service module to make sure that that's in place. And then we've also been working with the Boeing company to work on the exploration upper stage, and that's more thrust from the upper stage. So rather than change the boosters on the side, we decided to go from roughly 105 metric tons capability to low Earth orbit, from 70 metric tons in low Earth orbit capability to 105 metric tons. We do that by adding an exploration upper stage. And we're right in the middle of preparing for a preliminary design review for that activity. That preliminary design review will be in December. That upper stage builds off a lot of the heritage of what we have in the core stage. So I talked to you about the tanks down at MAF. Those same tank diameters are used in the exploration upper stage. Some of the manufacturing is the same. All those pieces kind of fit together. Then all this kind of goes together at MAF, at Marshall Space Flight Center, where we have some structural test articles where we actually put the core segment together. We'll simulate the strains that come from the boosters on the side into that tank, and then we actually plan to take those tanks to failure. And part of the reason we're going to take those tanks to failure is we want to understand how much margin is in that big core structure. And if that margin is where we think it is, we may not have to do a redesign of the core structure. We may be able to go to the next segment of boosters on the side and still support this activity. So the simple answer to your question really is all these pieces are moving forward. We've got activity heading on each one of these. We've got hardware in manufacture. We've got teams moving forward. You know, these are not paper designs. We are really ready to move from EM1 to EM2, and then we'll move into a flight rate roughly about once per year after that time frame, as soon as we can get that. So all that work is in place. And again, you know, it sounds maybe easy to you, but especially today, when I see the workforce and I know how much engineering and how much work went into this activity, there is nothing that is shortchanged. These folks are working really hard. They are really ready to go support these missions. So thanks.
Great, thank you. And before we take our next call, we had a request to identify yourselves before you speak for the folks on the phone line, please. Thank you. Do we have any questions in the room right now?
Thank you. Sean Costello, spaceflightinsider.com. A question for Alex. Relative to your successful 2015 test of QM1, could you speak to any design or engineering modifications that were made or integrated into QM2 that you were particularly interested in seeing continuous improvement or whatnot?
Yeah, this is Alex Priskos. There is one in particular that we're very excited to go see, and it's actually, when we ship the nozzle, we ship it in two pieces. The first part of the nozzle is put into the motor here at ATK, and then the back half, or what we call the rear part of the exit cone, is shipped separately to KSC, and they're joined together, and we have a joint there. And we have used various materials. We had a heritage material, which was an RTV, which we kind of pumped into that joint. It was really a difficult operation for the operators at KSC. So on the last test on QM1, we tried to replace that RTV with an O-ring. It worked fine. It worked great. But it frankly was scorched more than we liked. So we went with a slightly different design, and we got different materials in there. We got carbon fiber ropes. And so one of the things that I'm really looking forward is looking at those carbon fiber ropes, how did they perform, and then making a down select on the actual joint configuration we use on EM1. So that's just one of many, but we have 84 different design objectives. That's one that's going to result in a real decision here as we go forth in the next couple of months.
Thank you.
Great, thank you. And we'll go to the phone line.
Our question is from Stephen Clark with Space Flight Now. Your line is open, sir.
Thank you. A couple of questions from me. First, for Mr. Gerstenmaier. Are you still working towards the September 2018 date internally for EM1? And if so, how's that date looking? And what are what's in the critical path for that date? And also, maybe a question for Alex or Mr. Precourt. The modification from the 4-segment to the 5-segment motor, I'm curious what components with the design change from the shuttle boosters will you be reflying on EM1 or EM2 or any SLS booster? Thanks.
Okay, this is Bill Gerstenmaier, and I'll answer the first question. I mean, we're still kind of targeting, I would say, for September, but if I look at the schedules, if we just kind of lay them out a little bit, we're trending more towards maybe October, November kind of timeframe. So, you know, this is a continual process. We go look and see what hardware is available, what systems are available when, and we go look at the schedule and we optimize the schedule based on what we get. So it's like, you know, we look at the manufacturing and we determine, well, this component's going to be a little bit late, so maybe but this other component's a little bit ahead, so could we go ahead and move that other component up in the queue and still maintain the overall schedule? So we're off kind of redoing those schedules, and it's not it's almost a continuous process of keeping track of what's going on. So again, I think things are moving pretty good. You know, the teams are moving well towards those dates. In terms of what I consider on the critical path, there's really almost all our components are on the critical path to some extent. There's the service module with the European. We just completed the critical design review for that. There's some integrated work that needs to be completed over the next couple of months, and that will wrap up in October. But we're cleared to go ahead and start manufacturing. The actual flight article for EM1, the structure from the European service module is in Bremen to begin outfitting, much like the Orion capsule is. So that's probably close to being on the critical path. The crew module also is probably close to being on the critical path. And then all of it ends up down at the Cape, and the poor folks at the Cape are busy looking at umbilicals and where they need to be on the tower. They're looking at the mobile launch platform. They're building software down there, all those things. So they're also probably on the critical path to some extent, that all this hardware is going to come in at one time. So what we're trying to do is we shipped them some booster hardware earlier so they could actually begin some preparations for planning down at the Cape. So we're doing smart things where we have hardware available. We can move it forward to another area. We can let somebody get practice on it. So then when they get the real flight hardware, they've run through it a couple times with real flight hardware, and then that just uses the overall schedule thing. So again, I think the thing to be careful of is just because we have problems doesn't mean it's a big deal. We're going to have problems. If you're building real hardware, you're building flight hardware, you're building these systems that are going to take us eventually to Mars someday, you're gonna learn some things along the way, and you're gonna have to adapt to those. So don't expect us to not be learning things, not finding things don't work exactly right. That's exactly what we ought to be doing. And then the beauty is just step back and watch how the team can handle the problem. So as you saw today, the sequencer didn't do exactly what it was supposed to go do. The team stepped back, they thought about it, cool, calm day, they figured out what they needed to go do, and they were able to go ahead and do their activity. So that's the nature of our business, especially the nature of development. You'll see things pop up, you'll see us kind of fix them and move forward. So again, I think we're in pretty good shape for EM1, and we'll just keep moving at the right pace.
Okay, let me see if I got the question right, and I'll try and take the second part of that. I think I got the second part of that this is Alex, by the way. I think I got the second part of that question is what's similar to the shuttle design that we're firing on this booster, and what's different. And in real simple terms is you know, the outside of the car looks the same. When you lift the hood of the vehicle, almost everything else has changed. The propellant is largely the same chemistry. It's not exact, but we had to change the grain configuration inside because this vehicle's a much different vehicle. Max Q happens at a different time, so we had to change the propellant grain. We obviously, for performance and cost reasons, as well as how we're going to evolve this program, we don't have a recovery system on these boosters. We got plenty of assets to do what we needed to do, so we removed the recovery system. That was over 10,000 pounds apiece in inert weight. We moved the aft attach point on the booster back so that we could maximize the volume of the liquid core stage. We've also done some extra qual testing and enhanced the strength of the forward skirt with some stiffeners. We earlier conducted two full-scale tests on those, and they performed marvelously. And let's see, several other changes. We changed the nozzle, as I mentioned earlier. We opened up the throat. We got the fifth segment in there, which gives us the extra energy that we need. We got a brand new avionics system. The avionics system that flew on shuttle was all analog. This is state-of-the-art digital avionics in separate boxes. The other one was all consolidated into one package. I could go on and on and on, but you kind of get the drift. When you lift up the hood and you look inside, most of the other things are very much more modern and have changed for this specific vehicle and this mission.
And this is Charlie. Alex, I'll add that part of the interesting feature is the cylinders. We can get you the data on this, but they are, in fact, previously flown on shuttle, and we can get you the ones that each of these 5 segments, the shuttle flights that they were on before. And the other hardware that comes from previous shuttle flights, a lot of the nozzle, the metal parts of the nozzles, which are overlaid with carbon phenolic and other insulating materials. Those internal metal parts are heritage from the shuttle program too. Everything else, though, it's pretty much brand new.
Thank you. Do you have any more questions from the room in the back?
Kind of an easier question for you guys this time around. You got QM2 under your belts, you're done with that, and you're going to be moving on to EM1. Is this a point from a logistical standpoint where you guys kind of catch your breath and say, okay, let's move on? Or is it like there's just no pause, you guys got to keep going? Can you give us an idea what's going on behind the scenes with the team?
This is Alex. We'll probably take a pause for about 48 hours.
If that.
If that. There's a lot. This was a big deal today. This design certification review coming up in August for us is a big deal, and at the same time we're building production hardware, right? So there's a lot going. I get visions. You know, I can't believe it. Next fall seems like it's only a week away. At least that's what it mentally feels like to me. So it's going to be pretty intense all the way to delivery of the hardware, putting it together down at KSC.
And if I could add to Alex's comment, this is Charlie, from the Orbital ATK team's perspective, we have been in a cycle of developmental kind of work for quite a few years now. And this solidifies the design of this booster. So we'll be transitioning to a production mindset where we want to make it identically each time we make it. The cake recipe has to be the same, so we get the same product each time. So we need to move our mindset back to production, course, we've been in a period of high developmental activity. Those are two different mindsets on the factory floor in our back offices and engineering. We've become pretty sharp penciled with our developmental skills. Now we gotta make sure we can build this thing precisely each time. So we're constantly thinking about ways to organize around that going into the future. Like Bill said earlier, we're already building the first production hardware for EM1, and we're excited to be making that transition. But I don't think it'll make us slow down much.
You know, and I think, you know, this is Bill, again, I think you also ought to look at the whole breadth of the program. It's not just the booster things. Look at what we're doing with SLS. Look what we're doing with Orion. Look what we're doing with the Europeans. Look what we're doing down at the Cape. You know, we're in Cleveland with the vibration test of the European service module. So I mean, we are all over. This collective team is probably doing more development activities than we've ever done before. And then we're actually building the concrete plans of how we're going to really use this hardware to push human presence in the solar system. So this is really, really exciting. The other thing that I think is important to also to take into account is we kind of built off of the shuttle systems, but they're very different. You know, the manufacturing and the way we're building is dramatically different. We're focused on production and operations cost. We're making design changes. We're adding modern manufacturing where it makes sense. We're adding modern avionics where it makes sense. We're moving state of the art. So again, I think it's tough sometimes for folks on the outside to look and it's just another rocket, or it comes from here. We're moving forward. The engine controller on the shuttle main engines, that's a brand new engine controller built off of the J2X engine controller. That's state-of-the-art avionics. That's going to be tested down in Stennis here in July and August. That's moving forward. So, you know, I can give you all these little bits and pieces, but to really comprehend how big this program is, you kind of got to go out and you got to kind of tour the country and go talk to the folks that are doing the work. And then you get a chance to see the breadth of this absolutely amazing team that is giving America the chance to move humans into deep space, which is absolutely phenomenal. And I'm truly blessed to kind of get to see this at a top level. And then occasionally when I can't stand Washington anymore, I go to some remote location where something cool is really happening. And I can go pretend like I'm an engineer for a momentary bit of time, and then I'm ready to go back and get the teams motivated and go back and do my day job in DC. So you got to see something very, very special today.
On that note, we'll go back to the phone line.
We have a question from Ken Kramer with Universe Today. Your line is open.
Hi, thanks for taking the question and congratulations on a great test. Couple of questions, if I can, for whoever wants to ask them. Can you say when will you finish casting all the 10 boosters segments? When will you start building them up in the VAB? And I'm wondering, to go back to the pressure question, did you have to reinforce at all the casings at all? And are you using margin that was left over from the shuttle program? Thank you.
A lot of things embedded in there.
Yeah.
You want to team on it, or? The schedule for the manufacturing, as Alex said, gets us to a point where we can have all of the segments delivered to Kennedy by next fall. We will roughly do one a month. I don't have the exact schedule for you for that, but we've got 7 more to go. So we'll spend most of next year getting those done. Along with that, we've got nozzles to build up and so forth, and all of that will be ready for shipment to Kennedy. And then they will start their flow. Alex, you may be more familiar with that than I on the flow down there, but our hardware will be rolling on trains out of here over the course of the late part of next year.
So again, this is Alex. As Charlie said, we'll ship things out of here in the fall. Right now, notionally, the schedule is we'll start to stack the boosters. We'll actually do some work on the aft segment in what we call the RPSF to get it ready, and then it'll go over and we'll begin stacking probably in the spring of 18, okay? And that will commence the buildup of EM1. Relative to your other question, which I believe was, did we have to do anything to strengthen the case, or did we use some of the margin that was in shuttle? We didn't do anything significantly. We did one minor thing, and it really didn't strengthen it. We could get rid of what we called a stress riser. We used to have some reinforcing some reinforcing bars that went around the outside, and they would tend to corrode, and you'd have to worry about that. We really didn't need them, and so we machined them off, and so that helped from that aspect with those stiffeners. And in terms of the case itself, no, we didn't do anything to increase it. Did we push it a little harder? It had a little extra margin. We used a little bit, but very, very slight. It's not significant enough to really talk about.
Thank you. Next call from the phone.
We have a follow-up from Bill Harwood with CBS News. Your line is open, sir.
Yeah, thanks a lot. Hey, just out of curiosity, how many segments, usable case segments, do you guys have? In other words, how many SLS boosters can you assemble as of today if you don't build any more? Thanks.
So NASA in our inventory has enough for, this is Alex, NASA in our inventory has enough for 8 flight sets of the metal
Thank you.
boosters. Yes.
Thank you. And we have a question that was emailed to me for Charlie from Jeff Faust at Space News. How does this test and overall SLS booster work feed into Orbital ATK studies of a possible EELV class launcher?
Well, I mentioned a little earlier that we've been in the development phase of booster work for several years now. I think it goes back to about 05, 06 timeframe. We have developed and flown several new booster systems. We do the second stage for the Antares vehicle. We're also, for the future EELV, we're on contract now with ULA to do the follow-on strap-ons for the end of the Atlas program and then into the Vulcan booster that will come along for that. We're also in a research and development phase with the Air Force on a booster concept that would be a core booster for a future satellite launcher as well. So there's a number of developments that are in work, and I would tell you that what we've done, to Bill Gerstenmaier's point earlier, we have taken advantage over the last 10, 15 years of a lot of developments in manufacturing skill and technology, things that you don't see unless you do look well under the hood. Looks like the same on the outside, but it's not on the in. We have rapidly or increased the rapidity with which we can put together a booster on the assembly line, decreased a lot of the flow time for that. So I would tell you that the real answer to your question is that all of these developments feed upon each other because the technologies that we use, both in the design and in its manufacture, feed upon each other from one design to the next. And so whatever we do with a given concept or a given motor system, we will use the best of that on the next design. So when NASA gets to a point where they may need more thrust than this booster can put out, we will leverage a lot of that work on that future design. And that's just the nature of the way we do our business. So thank you for the question.
Thank you. Do we have any additional questions from the room?
Hi, Jason Hicks from the Planetary Society. With the election coming up and the new president coming in office, there's obviously going to be some scrutiny on NASA's current programs. And this was a very visible milestone of what the program has achieved thus far. How important are milestones like this to show the public and to show Congress and a new president of the progress that's being made in terms of what their plan will be going forward?
You know, again, maybe I kind of look at it a slightly different way. I think it's not so much the milestone that shows what we're doing. It's really the fact that the teams are really doing all this work, and it's fortuitous we happen to have a couple big events this year and then they work out. That's not by design. It's the engineering work, it's the design work, it's the activities we're doing moving forward. So I look at it as if we can essentially keep our focus and keep delivering and deliver to the schedules and the budgets and the promise of what we've got, I think we have a very capable vision that actually moves the nation very far forward in moving human presence into space. This is a very capable system. It's not built for just essentially 1 or 2 flights. It is actually built for multiple decades of use that will enable us to eventually allow humans to go to Mars. These are the first steps. This is a tremendously complex program. I think if we can show with our evidence by just direct work of our folks, steady progress moving forward, I think we can, that helps build support for our programs moving forward. So I think the best thing we can do is just kind of stay focused on what we're doing, keep working, don't overreact to the schedules, don't overreact to the pressure of delivering on a certain date, make sure the hardware is really ready to go fly, make sure the design is really solid. You can sometimes cut short a little bit on development, and then you'll pay for the rest of the time in production. And we don't want to do that. We want to take the time to get it right and move forward. I think the other thing that's really important is we also have to step back. And today we're focused on the SLS and Orion, but while we're here, 3 crew members on board the space station, we're getting ready for a launch to the space station in a couple of weeks from Russia. We also have a program actively working to provide the capability to bring transportation back to the U.S. so we can augment what the Russians do. So this human spaceflight program has a real near-term aspect of flying crews, doing things in space, doing research that benefits every one of us here on the Earth, as well as this longer-range strategic vision of building this capability that takes many years, maybe 5-6 years, to actually put the hardware together to go fly. So I think if you look at the continuum of this program, it may not be optimum from anyone's particular standpoint if you want to optimize for a particular aspect, but if you want a robust program that can keep this nation as a leader in spaceflight, this is a human spaceflight program that I think any country would be lucky to have, and we're really blessed that we have this program in this country. And now hopefully the political environment will see that. They will recognize what we have and can use you, the public, to convince them and to show them why you came out here, why you made the journeys here to see this activity. You can express your desire of what you want to go do, and I think that helps us keep moving forward.
Thank you. And I believe we have time for one final question.
Hi, I'm Nelson Phillips with the Box Elder News Journal here in the Valley. I'm 49 years old. Am I going to see a man on Mars? If you guys don't know,
yes.
Who would?
Well, the answer is yes. And I would say man may be the wrong word. You will see a human being on Mars.
We gotta hold you to that.
You got it.
Any idea of the timeline? I know that's really unfair.
Again, we're still on track to have the ability to put humans in the vicinity of Mars, maybe kind of fly around mission without a Mars lander roughly in the 2030s. And that's what we've been tasked to do. These systems, these schedules I laid out to you with a lot of challenges between that, give us that capability. We have other technology we've got to work on. The entry, descent, and landing capability into Mars to actually put humans on the surface of Mars. We've got to start advancing that. We're looking at that now, working that. We're also working on the habitation systems, and we're using space station to do that today. So we have systems on board space station that generate oxygen and scrub out carbon dioxide and recycle water. They work well as long as you can have a nice supply line back and forth to keep those systems operating. We need to really build that next generation of systems that are low maintenance and highly reliable. We'll get a chance to do that on space station. We're talking about potentially putting a habitation module somewhere around the moon in this proving ground region where we can build the skills that we need to go operate. We also have to change the way we operate with our crews. Today on space station, we can talk to the crews anytime they have a question. They can call down immediately. They have internet access. They have voice over IP phones. They're really tied back to the Earth. But when you go to Mars class distances, you now have a 22-minute, maybe one-way time delay. And so the crews are going to have to be much more autonomous. So we're going to use this vicinity around the moon to understand the risk posture, to understand what it's like to operate in the environment, to make sure the hardware is ready to move forward. So just as we're building a test program that are built up of developmental tests and qualification tests, I would say we're building a human spaceflight program that has that same approach. It starts with developmental tests, it starts with qualification tests of crews in space around the moon, and then eventually yields the ultimate goal, which is to Mars. And hopefully it's not just Mars only, but it really gives us the ability to move human presence in the solar system, and I think that's our ultimate goal.
Great. Gentlemen, thank you for the briefing, and thank you all for joining us today.